Hi everyone. Today we are going to discuss the classifications of circuit breakers. Okay, so different classifications of the circuit breaker. We have to classify circuit breaker based on the location, based on the external designs, based on the medium used for the arc quenching. Means whatever arc is formed between the contact of the circuit breaker, we have to remove that arc by using different medium. It can be air, it can be oil, it can be some chemicals. Okay, so first of all we have to classify it based on the voltage. Here they have mentioned the range of the voltages, so low, medium, high, extra high and ultra high voltages. They have listed the range of the voltages. Based on this we have to classify the circuit breakers. Okay, see, next classification based on the location. Okay, based on the location we have to classify as indoor type and outdoor type of the circuit breakers. Next, based on the external design, we have to classify as dead tank type and live tank type. Okay, and this is a very important type of the classification of the circuit breaker, that is based on the medium used for the arc quenching. Whatever arc is formed between the contact of circuit breaker, we have to remove. We have to remove means quenching that arc or extinguish that arc formed by using the mediums between the two contacts. We have to use different medium, and we can remove that arc formation when the fault occurs in the system. But we have to classify the circuit breakers. First is air brake circuit breakers, means medium used as the air. Next is oil circuit breakers, medium between the two contacts. Dielectric medium is oil, air plus circuit breakers. Then sulfur hexafluoride, SF6 we have to use between the two contacts of circuit breakers. Next is vacuum circuit breakers. Okay, these are the very important type of the circuit breakers, that is based on the medium used for the arc quenching. Right. Here medium used between the two contacts of circuit breaker, that is the classification based on medium used vacuum circuit breaker, air, SFC circuit breaker, and also one more is oil circuit breaker. Okay, so here we have to first see the type of the air circuit breakers. See here, this is the air brake circuit breaker. Air brake means what? Here we are using air as the medium to extinguish or to quench or to remove the arc formed between the two contacts of the circuit breaker. Okay, so we have to remove that arc by using the air as the dielectric medium between the contact. Okay, between the two contacts. Okay, air is nothing but it should be at the atmospheric pressure. Okay, we have to use as in the arc extinguishing medium. See, this figure shows the air brake circuit breaker. Okay, see it has the two pairs of the contact here. One is main contact here showing, and one more is arc contact. Right, two contacts it is having. One is main contact and one more is arc contact. There are two contacts are there. The main contacts carry the what? Current when the breaker is in closed position. Okay, see, when the breaker is in closed position, position means what? There is no fault condition, it should be a normal condition. At the normal condition of the system, normal supplying voltage and current, at that condition circuit breaker is in the closed position, right? So the when circuit breaker is in closed position, the main contact carries the what? Current. Okay, but at the it should have the low contact resistance when the contacts are opened. Okay, see, when it is in the closed position, main contact is closed and contacts arcing contacts also closed. When the fault occurs, it should be opened. Okay, when fault occurs in the system, fault means the circuit breaker should be open, that is the main contact opens. Okay, whatever it carries the current before fault occurs, that is in the closed position, it carries the current. When it opens, that main current carrying, that is shifted to the arc contact. Is it clear? ನಾರ್ಮಲ್ ಕಂಡೀಷನ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಕ್ಲೋಸ್ ಪೊಸಿಷನ್ ಇರುತ್ತೆ, ಅವಾಗ ಮೇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಏನು ಮಾಡುತ್ತೆ, ಇಟ್ ಕ್ಯಾರೀಸ್ ದಿ ಕರೆಂಟ್. ಓಕೆ, ಸೊ ವೆನ್ ಫಾಲ್ಟ್ ಆಗುತ್ತೆ, ಫಾಲ್ಟ್ ಆದ ತಕ್ಷಣ ದಿ ಕಾಂಟ್ಯಾಕ್ಟ್ಸ್ ಆರ್ ಓಪನ್, ಮೇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಓಪನ್ ಆಗುತ್ತೆ, ಇಲ್ಲೇನು ಕರೆಂಟ್ ಕ್ಯಾರಿ ಮಾಡುತ್ತಲ್ಲ ದಟ್ ಈಸ್ ಶಿಫ್ಟೆಡ್ ಟು ದಿ ಆರ್ಕ್ ಕಾಂಟ್ಯಾಕ್ಟ್. Is it clear? When contacts are opened, the main contacts separate first, then arcing contacts still remain closed. Arcing contacts remains closed. Therefore, the current is shifted from the main contact to the arcing contacts. Okay, the arcing contacts separate later on, and arc is drawn between them. Okay, ಆಮೇಲೆ ಫಸ್ಟ್ ಏನಾಗುತ್ತೆ ಮೇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಓಪನ್ ಆಗುತ್ತೆ, ಆವಾಗ ಆರ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಕ್ಲೋಸ್ ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಕರೆಂಟ್ ಶಿಫ್ಟ್ ಟು ದಿ ಆರ್ ಕಾಂಟ್ಯಾಕ್ಟ್. ಆಫ್ಟರ್ ಸಮ್ ಟೈಮ್ ದಿ ಆರ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಆಲ್ಸೋ ಓಪನ್ ಇಟ್. When these two are opened, there is a arc formation, arc formed between them. Okay. In airbag circuit breakers, the main principle is that at the high resistance, it should be applied for the arc extinguish. Arc extinguish, how to do the arc extinguish between these two contacts? Arc, how to remove the arc between two contacts? One is what that high current we have to remove. Due to the high current, that is in the fault condition, the arc is formed, right? So that we have to minimize the current means we have to increase the resistance between the two contacts, or we can increase the distance between two contacts, right? Or we can do the do cooling between the two contacts. So by using the different methods, we can extinguish, we can remove the arc formed between the two contacts. Okay. So that the arc resistance is increased by length, increasing the length between the two contacts. Okay, resistance how to increase it? Length ಜಾಸ್ತಿ ಮಾಡೋದ್ರಿಂದ resistance ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So resistance ಜಾಸ್ತಿ ಆದ್ರೆ current flowing between the two contacts is decreases, so that arc is quenching, arc extinguish we can do it. Okay, or we can splitting the between them, and or we can cooling the arc. Okay, by using these methods we can extinguish the arc between the two contacts. Okay, the arc length is rapidly increased here. The arc length is rapidly increased, so it employs the arc runners also. See here, these are the what arc runners is nothing but this is the arc runners. Okay, see ಇಲ್ಲಿ ತೋರಿಸ್ತಾರೆ, this is the arc runners. ಯಾವಾಗ ನಾವು ಲೆಂತ್ ಜಾಸ್ತಿ ಮಾಡ್ತೀವಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಲೆಂತ್ ಜಾಸ್ತಿ ಮಾಡೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, along with arc runner this also increases, arc runner also increases, and also arc chute, arc, this is what arc chute, this also increases. Okay, so the arc moves upward by both. This arc, whatever arc form is there, that should be moved upward, so that by this motion of the upward motion of this arc by electromagnetic or thermal effects. Okay, it moves along the arc runner and then it is forced into the arc chute. Right? It is split by the arc splitters. These are the what splitters. Okay, this is split by the arc splitters. A blowout coil is employed to provide the magnetic field. See here, a blowout coil is employed to provide the magnetic field to speed up the arc movement and to direct the arc into the arc splitters. Right? The blowout coil is not connected in the circuit permanently. Okay, it comes in the circuit by the arc automatically during the breaking process. Right? The arc interruption is associated by the only current. We have to make it the current is zero. In the case of AC circuit breaker, okay, it is we have to make it current is zero. Okay, high resistance is obtained, nearly current push becomes a zero condition. Okay, the AC air brake circuit are available in the voltage range around 400 to 12 kilovolts. Okay, they are widely used in the low and also medium voltage system. They are extensively used with the electric furnaces with the large motors carrying frequent starting, right? So the air brake circuit breakers are also used in the DC up to the range of 12 kilovolt. Okay, this is the what air circuit breaker. Air circuit breaker ಅಂದ್ರೆ ಏನು ಇಲ್ಲ. So ಇಲ್ಲಿ ಎರಡು ಕಾಂಟ್ಯಾಕ್ಟ್ ಇರ್ತಾವೆ, ಒಂದು ಮೇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇನ್ನೊಂದು ಆರ್ ಕಾಂಟ್ಯಾಕ್ಟ್. When in the normal condition these should be in the closed position. So in the normal condition the main contact carries the current in the circuit breaker. When fault occurs, the heavy current occurs, the main contacts open first. At that time R contact should be in the closed position, so that this current shift to the R contact. Then after some time the R contact gets open it. Okay, so whatever heavy current is there between them, it forms the arc. Okay, there is an arc formed between the two contacts. We have to quench or extinguish that arc formed between the two contacts by using different methods. One method is what we have to make it high resistance between the two contacts. With the high resistance we can minimize the current, so that current becomes zero. How to increase the resistance between the two contacts? Means we have to extend the distance between the two contacts, means lengthening the lengthening here. Okay, so that by lengthening of these contacts, the arc contact whatever is there, it moves along with the arc runners and with the arc chuti. Okay, the splitters are provided by splitting the arc splitters here, so that whatever arc is formed, that is moving upwards by using magnetic field and thermal effect. So whenever arc is extended upwards, okay, there is a lengthening also increases, length also increases, resistance also increases, and you have to make it a current at 0 level. And one more method is to make it a cooling method between the two contacts. Cooling method you can also use to quench or extinguish the arc. Okay, and splitting method also. See, whatever arc is formed, we have to split the arc. Okay, we have to split the arc by using these splitters. Arc ಏನು ಫಾರ್ಮ್ ಆಗುತ್ತಲ್ಲ ಅದನ್ನು ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಬೋದು by using these splitters. Arc divide ಆಗುತ್ತೆ. So arc divide ಆಗೋದ್ರಿಂದ we have to minimize the arc form. Okay, so current becomes 0. Then arc is extinguished completely. Is it clear? See, this is in the closed position where it is in the normal condition, and this second figure is in the when the fault occurs, the main contact opens and that current shift to the arc contact. See, ಇಲ್ಲಿ arc close ಇದೆ, ಇಲ್ಲಿ open ಇದೆ, right? So after some time arc is also opened it. Okay, then this arc moving upwards by magnetic and thermal effect. Then arc is splitted here by using the splitters. Okay, we can minimize or we can lengthening this by using the arc runners. Okay, so we can increase the resistance, and due to the more resistance, the current becomes 0. Okay, so this is your 8-way circuit breaker. We can use for AC and also for the DC. AC range is about 400 to 12 kilowatt, and for the DC circuits we can use up to 12 kilovolts, right?